right, so we're going to finish up what we're going to be doing in Chapter 9 with the first part of 9.2. And that's going to be graphing in what we call polar. So that's going to be one more mode we look at on the calculator. It's the last mode that we look at. And polar is a little bit different than parametric. When you do function or parametric, either one, function and parametric are both based off of this kind of graph. You have an x-axis and a y-axis on the paper. When we graph something in a polar system, not only is polar a different way to write the formula, but it uses a totally different kind of graph paper. It's not rectangular. The kind of graph paper you're going to see in polar is circular. So it's circular instead of rectangular. So we'll look at how you graph points on circular graph paper. And I do have some circular graph paper. I think it's in the back if you want to take some for homework. But I don't think there's that much polar graphing, so you could really just try your own and then just use the same grid for all the problems. I'll show you. So it's a lot easier to draw some types of curves in a polar system. The one thing that's extremely simple to draw in polar is a circle. So let me show you 3 different ways we can draw circles, starting with function, then I'll do parametric, and then I'll do polar. If you want to draw the equation of a circle as a function, well, first of all, does a circle pass the vertical line test? No, then it's not a function. So technically I really cannot draw circles in function mode. But I kind of can cheat and draw the top half and the bottom half separate. Okay, that's the best I can do. So as a function, we have to use the equation x squared plus y squared equals r squared. That's how you draw a circle as a function. And I need y to be by itself. So to get y by itself, I'd have to bring the x squared to the other side, and then I'd have to take the square root. To bring the x squared to the other side, I would subtract it. And then to get rid of the exponent of 2, I would take the square root. So let's type that in and see what it looks like. All right, so I'm going to switch over to function. And I have to pick a radius. Let's just draw a circle with a radius of 3. So I'm going to do the square root of 9 minus x squared. Now, I'm just doing the positive root to start. I'm going to hit graph. I'm also going to do zoom 5 to make it look proportional. And I could zoom in a little bit. There you go. So there's the top half. And then if I want to graph the bottom half of the circle, I need to do the negative square root. Because remember, there's always 2 answers when you take the square root. So square root of 9 minus x squared. Minus x squared. Okay, so there's the formula we had to use. And here's what the picture looks like. It looks like a circle, but it doesn't even connect, right? And I can't do anything about that because the mode that I'm in is not designed to draw circles, and I'm trying to make it draw a circle. All right. So you have to type in all that stuff to kind of get a circle. So the way we learned yesterday, that was parametric. In parametric, we can draw a circle using the 2 formulas, r cosine theta and R is sine theta. So I'm going to draw a circle with the same radius again. I'm going to use a 3. So I'm going to do 3. Not theta, t. We're going to talk about theta today. So it's t. 3 cosine t and 3 sine t. Okay, so here's the formulas in parametric. And there's your picture. And that actually would look like a circle if I went from 0 to 2 pi. You have to make sure your parameter goes all the way around to get the full picture. And that's pretty good. All right, so now I get a picture that actually looks like a circle. I probably need to adjust my t-step a little smaller so there's no gap at the end there. But I could do that and you get a pretty good picture. All right, so 2 formulas we had to type in, but the picture is much better than the top one. Yeah?
So the values that you're using, the 9 and the 3, are those just values you're making up, or do those have specifics?
I just picked it so I could draw a circle that was that size.
Okay.
The idea is I'm just drawing circles.
Okay, but it's not anything to do with the equation itself.
No, I could make the circle any size. Now, polar. So this is the mode we haven't done yet. Go to polar. Now you get a screen that says R equals. And if you want to draw a circle with a radius of 3, that's all you have to put in. Put in a single number. R equals 3. Hit graph. And by far, that is the best way to draw a circle. Okay, simplest formula, and the picture looks good. So three different ways of making circles: the function mode, the parametric mode, and the polar mode. Now, polar is the best for making circles. I would say function is the best for drawing lines, because in function mode you can use y equals mx plus b. It's a pretty basic formula. It's very easy. If you try to draw lines in polar, that starts to get complicated. So what system you use would depend on what kind of shape you're trying to draw. Anything that fails the vertical line test, you really want to stay away from function mode, because function mode isn't designed to draw things that fail the vertical line test. Parametric and polar are. So any question on the comparison between the 3 modes? And this is the mode we're going to study today, polar. All right. So let's look at polar system. So in a polar coordinate system, the center point is called the pole. You can also call it the origin. And there's really only one axis, and that's called the polar axis. Everything is going to be measured off that horizontal axis. Now, depending on the polar graph paper you use, it may have backgrounds. It may have less lines for circles. It may have more lines. It's just the size of the graph paper. Okay? I generally use this one, so it doesn't look too squished. But if I had to draw something that was a really big shape, I may need to use smaller scale graph paper. Now, there's lines that come out from the pole to the edge. And these lines, in my graph, occur every 15 degrees. I'm not going to label them all, but generally you have some type of lines that come out from the center. I've seen them every 10, like 10, 20, 30, 40, so then you'd have more of them. I've also seen them as few as every 45. Okay, but my particular graph paper does 6 of them per quadrant. 1, 2, 3, 4, 5, 6. So that breaks the quadrant into 15-degree wedges all the way around. So let's talk about how you write down a coordinate in polar. First of all, it doesn't use an x and a y. There is no such thing as x and y in polar. X and y is a rectangular concept. We're looking at a circular concept. Since we're dealing with circles, what do you think r would stand for in this coordinate? Yeah? Would be a radius. Yep. And the radius is a distance from the pole to the origin, or from the point to the origin. So r is a radius, and theta is an angle. So when we graph a point in polar, we're going to start by moving out a certain distance from the origin, and then we're going to do a certain amount of rotation represented by an angle. There's an example of a polar coordinate, 3, 45 degrees. What that means to do is move 3 units away from the center and then rotate 45 degrees. Now, when we move away from the center, that's kind of like x in terms of the movement. But when we rotate, we don't rotate up, down, left, or right. How do you describe a direction of rotation? There's really 2 ways to describe it, yeah?
Clockwise and counterclockwise.
Right. You're either going to rotate clockwise or counterclockwise. So let's kind of go over when you do which one. So in terms of graphing a point in polar, r is very similar to how you would handle x. If r is a positive value, you're going to start by moving to the right. If r is a negative value, you're going to move to the left. So let's say r was 2. If this was your graph paper, and r was 2, well, positive 2 means you would start by going right 2 units. And you'd be starting from right there. What you would do from that point now is rotate a certain amount of degrees or radians. Rotation would be measured either clockwise or counterclockwise. If your angle is positive, you're going to rotate in a counterclockwise direction after you do step 1. If your angle is negative, you're going to rotate in a clockwise direction after you do step 1. So you either move left or right, and then you rotate clockwise or counterclockwise after you do step 1. So that's kind of like an XY coordinate. To graph an XY coordinate, you first move to the left or right, and then from there you move up or down. Well, the difference in polar, there's no up or down. It's clockwise or counterclockwise. So what we'll do is we'll just practice graphing a few different points in polar. We never really even get to graphing a full equation on the calculator. Just single points. In points, we don't use the calculator. We do it by hand. Okay, so let's look at this one. 3, 45 degrees. What is my distance that I'm going to be from the origin? Yeah? 3 units. And which way am I going to go? 3 to the right or 3 to the left?
Oh, me?
Yeah.
3 to the right.
3 to the right. So we're going to start by going 3 to the right. I'm going to put a temporary mark right there. That's not the answer. That's just where I'm going to do step 2 from now. So I went 3 to the right. I'm going to erase that. And now I need to rotate how many degrees? Just the number of degrees. That's all I want to know.
45.
So I need to rotate 45. And now I need to make sure I do it in the proper direction. Is it going to be clockwise 45 or counterclockwise? Yep. Counterclockwise because it's positive. So 3 to the right, and then rotate 45 degrees. And that's how you graph the point 345. Now, I don't have as many lines coming from the center, so this graph paper only breaks it down into 90s. So you're going to have to estimate 45 the best you can. Question on? Yeah.
So is that just you're just plotting a point?
We're plotting points. Yep, that's all we're doing today. We're going to plot points. Plot points and convert points. Everything's about points. Okay, let's look at this one. -2, 75 degrees. What's R telling me to do in this case? Yep.
Move left 2 units.
Move left 2 units. Now, that is where you're going to measure your rotation from. This is where you're starting from. From this point, how many degrees are we going to rotate? Yep.
75.
We're going to rotate 75. And which way are we going to go? Clockwise or counterclockwise? Counterclockwise. 75 degrees puts you most of the way through the quadrant. Okay, so it's basically, I don't know, just estimating, about right there, 75 degrees. So left 2, and then rotate 75 degrees counterclockwise.
We're just plotting dots here, right? Just
Yes.
Point, right?
Yep. Any question on that one? All right, let's try another one. 3, -60. All right. What am I going to start out with? Yeah.
Move right by 3.
Move right 3. And now from that position, you're going to do a rotation. You need to know how much rotation and what direction. Yeah.
Clockwise 60 degrees.
Clockwise 60 degrees. So 60 degrees puts you 2/3 of the way through the quadrant because 90 is all the way through it. So right 3, and then clockwise 2/3 of the way. Just estimate it right about there. Just make sure it looks like it's more than half. Questions on it?
Wait, can you go back to your last one? So you go -2 and clockwise down. It was like
We went -2 and then we went counterclockwise. We went
yeah.
this way. Because it's a positive angle. Yep. So counterclockwise. Yep. All right. -4, -3 pi over 2. Might help to write that in degrees. It's not necessary, but if you think better in degrees, we can do it in degrees. What's -3 pi over 2 in degrees? Yeah.
270.
3 pi over 2 would be 270.
Oh, -270.
-270. Yep. Okay. So now, how would we graph that one? Just start with R.
Oh, you start asking me.
It'd be nice if other people volunteer. You're doing great, but I'd love to hear other people. Yeah.
And move left 4.
Left 4. So 1, 2, 3, 4. So we're going to start from there. And how much rotation am I going to do from that point?
Clockwise to the 270 degrees.
So we're going to rotate clockwise 270 degrees starting from here. So where's that going to put me? Yeah?
It's gotta put you on an axis, but technically you're doing 90 degrees counterclockwise.
Okay, we're going to talk about that in a second. So let's think of it as 270 degrees clockwise for now. Which puts me where?
The top axis, like at the top.
Right. So I'm going left, and then I'm rotating 90. 180, 270. So that's where it puts me. What's another way you could write that point besides -4, -270? Yep.
Positive 490.
Positive 490. So positive 4 would mean right 4 and then rotate 90. All right. Another way. Yeah.
Do 8 and 360.
What do you want to do for this number?
8.
That won't put you on a circle of radius 4. That'll move you out too far.
So you went down 2.
These are the only two choices you have for the first number. 4 and -4. Anything else won't land you on the correct circle. You're either going to go out too far or not go out enough.
So could you do -4, -1?
Let's see. So -4. 1, 2, 3, 4. And then -90 would mean to rotate clockwise 90 degrees. Okay, so we got that one. And then we had that black one's there. Another way.
With the black one, -270, you rotated they're both counterclockwise, but they're both negative.
Oh, wait a minute. What did I do there?
Yeah, I was gonna say, I realized I messed up. It's supposed to be on the bottom.
So -4,
I think the black one's wrong.
-270.
Yeah,
Let's
it's
see.
supposed to be clockwise. So it'll be the bottom.
Yeah, so that's gonna mess that. So yeah, -4 clockwise 270. So then what I'm gonna
make
do?
it positive 270, so we don't have to change anything.
We'll just change the problem then. So now -4 counterclockwise 270. So that works for the black one. Let's check the red one. +4 90. Okay, that works for the red one. For the green one, -4. And then how could I go like that? What would that angle be? Yeah,
-90.
-90. And how could I go? Let's see, I have 2 going that way. How could I go? No, let's do it. Actually, let's do it this way. Go right, and then go that way. What would that blue one be? Yep.
4, -270.
4, -270. So how many different ways were there to get to that point? Yep. 4. So in general, in polar, there are 4 ways to get to the point. You can rotate, well, you can go right and go clockwise. You can go right and then counterclockwise. There's 2. You can go left and then go clockwise. There's 3. And you can go left and you can go counterclockwise. There's 4. So 4 different ways to get to a point in polar. Now, compare that to this. If I wanted you to give me the coordinate for that point, how many ways can you give me a coordinate that correctly locates back up? Yep,
1.
just 1. So in a rectangular coordinate system, there is only one way to specify an exact location. In a polar system, there are up to 4. Sometimes there are only 3. If you land on the polar axis, you'd only end up with 3. But if you land anywhere else, there are always 4 ways to get to a point. And the easiest way to figure out the different ways is to draw it. You could try to come up with formulas to figure it out, but for me, I'm more visual, so if I can actually see where the point is, and then take my pencil and draw, then I can see how to do it. That's the easiest way. You wouldn't have to give me all 4 answers on a test. But when we start working with polar coordinates, maybe I write the answer like that on the test, and maybe you got an answer like that. Well, you'd have to know those are the same thing. Okay? That's why I show you how to write the different ways in polar.
So wait, did you say that any point that's on an axis will have 4, or any point that's not?
Any point that's not on the polar axis would have 4.
So the polar axis is just the x.
Yeah, it's like the x.
And that doesn't change even though you circle.
On the polar axis, you would only have 3. You would only have 3 ways to get to a point instead of 4. Because if you rotate if you go to the polar axis, like let's say you put a point right here, you can go right, and you can go this way. You can go right, and you can go this way, or you can go left, and then stop. You don't want to rotate at all. So that's why there's only 3 ways to get to a point on the polar axis. But every other point has 4. Any question on that? 4, yeah?
Sorry, so those last ones that we just did too, like examples 1 through 3, those would also have up to 4 ways of writing them?
Yeah. Because you could go this way to get to it. You could go that way. There's 2. You could go left and go that way. There's 3. You could go left and go that way, and there's 4. Yeah. You'd have to figure out what those angles are, but I think if you see it as a picture, it's easier than to try to do it all in your head. Okay, let's look at this one. 0, comma pi. Where's that one going to end up? Yeah?
Supposed to be at the origin.
Yeah, it's going to be at the origin because you're not moving out any units from the origin. So you have a point right there. But then it says the rotation is how much? What's pi?
180.
You have to rotate 180. So what you do is you take your point, and see how the green handle is at the top? You take it, and you rotate the green handle to the bottom. And that's your point. And the way I could check for that is I look for what's called the SF. Spin factor. So what I could do is when you graph this with like paper, I would take out like a magnifying glass, and I could see if you put your pencil down and you spun it in place. And I could check, because if I borrow a microscope from the science department, and I could see the little, like, the graphite kind of spinning in place. So I look for the spin factor. You know what I'm saying? Some of you think I'm serious. That's okay. I'm just kidding. So 0 pi is always at the origin. 0 comma anything, it just stays in place, it doesn't move. But how about if you put 0 as the second number? Is that going to stay at the origin? Yeah?
No, it's going to be polar axis.
It's going to be on the polar axis somewhere. So when your angle is 0, you either move left or you move right, and then you stop. And just like regular coordinates, you can end up in between circles. If you had 2.5 units, you could end up right in between the second and the third circle. All right, so that pretty much covers every different type of graphing. Positives, negatives, and zeros. Any questions on graphing a point in polar? Yeah.
So if you had something that was like 2.590, would
2.590, so now you're talking up here.
yeah, would you be able to do something like 2.5450 if you added 360 to it?
So technically you could put that point, and then you could just keep going around as many times as you wanted.
Yeah.
And then stop. We don't really count that as a different way if you decide to go around 6 or 7 times before stopping. But yeah, you could.
But if you had that to graph, that's
Yes. Yep. If you had something that has an angle bigger than 360, the first thing that I always do is subtract 360 from it to make the angle smaller. So you always want to be dealing with a number here that's between 0 and 360. Any more or less than that, and you're just going around extra times. Well, actually, negative 360 and 360. Okay. Any more than that, you're just making unnecessary revolutions. That's a good question. So, hopefully at this point you realize that there is more than one way to graph a point in polar. There's up to how many ways? Yeah? Up to 4. Up to 4. Yes, got it. 3 sometimes, but usually 4. Okay. So the last thing we're going to look at is how we change a point between polar and rectangular. Okay, both ways. And the main idea here is just making sure you get the right letter. Okay? In polar, what do we call the two things that they give us as a coordinate? They give us a something and a something, yeah?
Radius and angle.
They give us a radius and they give us an angle. Now, if they give you a point in rectangular, what do you call the two things? It's not a radius and an angle. Yeah? It would be an x and a y. So the goal when you are changing from polar to rectangular is to get rid of the r and the theta and somehow have an x and a y. Okay. So let's pretend like we had a point in polar. Let's take this point right there. If that was a point in polar, I would know two things about it. First thing I would know is that would be the radius of the point. It's the distance from that point to the origin. That would be my r. And the other thing I would know is how much rotation I did to get to that point. That would be my theta. Now, x and y is a horizontal movement and then a vertical movement. It's a different way to get this point. It's not a rotation. What shape do you think we could make here to help us figure that out? Yeah? Yeah, I'm going to make a triangle. And the goal is to figure out how much horizontal movement you had. That's the distance from the base, or that's the distance from the origin along the base of the triangle. And then how much vertical movement. That's the length from the base up to the point. So we've got to convert r and theta into an x and a y. Let's start with the x. What trig function would involve the two things that we're going to be given and the side that's adjacent to theta? Yep.
Cosine.
Cosine. So we're going to write down cosine of theta equals adjacent over hypotenuse. And how would we get x by itself there? Yeah.
Multiply each side by r.
Multiply each side by r. So there is a formula that calculates the x value of a rectangular coordinate using the polar coordinate. It's r times the cosine of your angle. And now, what trig function would we use to find y? So we have to involve the two things that we would know in black and the opposite side. Yeah. Would be sine. So sine is opposite over hypotenuse. And you're going to know the angle and you're going to know the r. How do you get y by itself there? So, quick.
Multiply by r.
Perfect. Multiply each side by r. And there is a formula to calculate y. It's r sine theta. So those are the two formulas that you use to convert from polar to rectangular. R cosine theta and r sine theta. Just fill in the r and fill in the theta. And straight. 2, negative 200. What's going to be my formula for x? Filling in my r value and my theta value.
For x, it would be 2 times cosine of negative 200.
Yep.
And then for y, it would be 2 times the sine of negative 200.
And what these two numbers are really representing is you are finding the base of a triangle and you're finding the height of a triangle. And the base and the height represent the x and the y. And we just round these off. So now it matters what mode I'm in, because I'm doing an angle. This particular problem I know is in degrees, because of the degree symbol. And type in 2 cosine negative 200. So negative 1.88. So the x value is negative 1.88. And now I need the height of the triangle. That's my vertical. And that's the y value. 2 sine negative 200. 0.68. Now just put them together and write your coordinate. Negative 1.88, 0.68. And that's how you convert a polar coordinate to a rectangular coordinate. We went from an r and a theta to an x and a y. So if you're going to make a reference sheet, those are two formulas I would definitely put on it. So any questions on converting to rectangular, going that direction? So the last thing to look at is how to convert the other way. It's really just as easy. What trig function did we not use here that we use a lot? Yeah. We didn't use tangent. And that's because tangent is going to be used to go this way. So in rectangular, they give you an x and a y. And now your goal is the opposite of last time. Turn an x and a y into an r and a theta. Well, I've got the same diagram I had last time. The difference is you're going to know this, and you're going to know that. You're going to know the two things I circled. R is the radius. But what is R in that triangle? Yep. It's the hypotenuse. And that's what you need to find. You don't need to find the base and the height. That's what you need to find the way we did it before. You need to find the hypotenuse. If you know two sides, how can you use these two sides to find the length of the hypotenuse? Yep. Use the what?
Tangent?
Well, tangent is going to be used to find an angle. So we'll talk about tangent. But you can't find the side with tangent, but you can find the side with another formula. Yeah? You can use the Pythagorean theorem. X squared plus y squared equals r squared. So the Pythagorean theorem will give you the r. Now, let's talk about the angle. What's the name of the side that's labeled y? What's the position of it? Yep. Opposite. And what's the position of side x? Adjacent. And what's the trig function that involves the opposite and the adjacent? Yeah. Tangent. So I could write down tangent theta equals y over x. Problem is, I don't really want to know tangent of theta. To write a point in polar, I need theta. So I need to get rid of tangent and get theta by itself. How do we get theta by itself? Yeah, exactly. We have to do the inverse tangent on both sides. And I'm going to write this down nicely on the next page. But that's the idea of how you find theta. It's the inverse tangent of y over x. Let me write that down nice. So, first thing you want to do is, you don't have to graph it, but you do have to know the quadrant your point is in. And the reason the quadrant is important is not for the r. R is just Pythagorean theorem. You can do Pythagorean theorem in any quadrant. But if you want to find theta, in quadrants 1 and 4, it is exactly what we said. It's the inverse tangent of y over x. The problem is, if you're in quadrants 2 or 3, that formula won't work. It almost works, but we have to make an adjustment to it. If you are in quadrants 2 or 3, you can use that formula, but you have to add 180 to it. To find an angle that's in quadrants 2 or 3, you can use inverse tangent y over x, but you need to add 180 to the formula. Or if you were doing it in radians, you would add pi. Now, these formulas cover what would happen if you're in quadrant 1, 2, 3, or 4. But these formulas do not cover everywhere you could be. Where else could you be besides quadrants 1, 2, 3, or 4? Yep. You could be on an axis. These formulas won't work on an axis. But the axis is the easiest angles to tell. If your coordinate has a 0 in it, then you know you're on an axis. What's the angle if you go right and then you stop? Yep, 0. What if you go up? Yep. And if you go left? Yeah. And if you go down, it's 270. So if you are on an axis, you need to memorize it would be one of those 4 answers. Other than being on an axis, those are the 2 formulas that we can use. So that's what I just said. And then R, well, that's the easiest one to find because it works the same formula all the time. It's just the Pythagorean theorem. It's finding the hypotenuse of the triangle. So we'll try one of those, and that'll be it. Okay, so 3, -5. First thing is, what quadrant is 3, -5 in? Yep. 4. Not looking for a perfect sketch, I just need the quadrant. So now, what's your formula for theta if you are in quadrant 4? Yep.
Inverse tangent y over x.
So inverse tangent of -5/3. And what it's going to do is it's going to give me that angle. It's going to give me an angle that goes clockwise. What kind of angle do we get when we rotate clockwise? Yep. Negative. And that's okay. It's going to give me a negative angle. Gives me -59. We talked about there's 4 different ways to write it. If I don't like -59, fine. Add 360 to it and go the other way. It's 300.96. And then to find your radius, it's r squared equals x squared plus y squared. So in this case, your radius is going to be 9 plus 25. And then just write that down as a coordinate. Square root 34, comma, 300.96. Okay, we can, I know we had to go a little quick through the last one. I think we did pretty good with everything else, but we'll spend some more time tomorrow and we can go over some more in writing from the homework. So the homework is on page 492, and it's 1 through 14.
Thank you.
That's the homework for tonight.